Starting with the name of Allah, the most gracious and the most merciful, a very warm welcome to everyone who is watching out this video. In this chapter, we are going to look at TCP IP protocol suite. So we will discuss TCP in this chapter. Actually, TCP is the heart of the suite. It provides a vast array of services. Therefore, it is considered as a complicated protocol. We have already gone through many versions in last or few decades regarding this TCP. So this chapter is going to be a bit long, as you can see from a slide numbers. If this is visible in this recording, it's going to be 132 slides, and each slide uh, it contains explanation of 5 to 10 minutes. So it's going to be a bit lengthier chapter of this whole syllabus, but believe me, this is very important concept. This TCP IP suite is very important. If you are studying wireless network communication, radio, mobile, or whatever you are actually, if whatever the networks you are studying, and whenever you talk about your transmission, then your TCP IP suite will always be concerned. So as this chapter is going to be a bit lengthier one, so let me give you just a detailed overview. First of all, I'll be making a video on each of these topics. So it's a chapter number 15, the book I'm following. Uh, First topic will be TCP service. TCP services. So this means in this video, I'll be only going through the TCP services. I'll cover the TCP features in the next video, then the segments in the next, then the connection in the next, then state transition diagram, windows, the flow control, the error control, some congestion control, the timers option, and the packages. We may not talk about the TCP packages. We'll look into the packages. What do we have? Then we'll see. But I think okay, I'll make video till the TCP options only. So let's move on without wasting our much time. So what do we have? So it's saying about okay, there is a figure. Okay, it's a 15.1 figure. Let's move to the figure. So this is a figure. This says okay, it shows a relation of a TCP to the other protocol in TCP IP protocol. So as it's clear, the pink color, this brown color, sorry, this brown color showing us okay, TCP lies between it obviously lies in the transport layer, but if we talk about its position, then it is between the application and the network layer and serve as an intermediary node between the application programs or the network operations. So although it's lying in transport layer, but it's also the it has an intermediate position between the application programs and the network program. So before before going into the much detail of the TCP, it's very important for us to explain some of the services that is offered by the TCP to the processes at the application layer. Where remember that I'm saying, okay, first of all, we would be studying the services offered by the TCP to the application, to the processes at the application layer. So let's see, we have detail of applications that are being offered. So first of all is the process to process communication. So many of you might have an idea about the UDP. So like the UDP, TCP also provides process to process communication using the port numbers. So using the port number, so we have different ports. So I guess we have gone through this concept. So if you think we have not gone through this concept of ports, then do let me know. I'll tell you in detail what exactly the ports are. So here few of the most well-known ports that are used by the TCP, like 7 for sending an echo packet, for discard the datagram that is being sent, or 11 for just to show active users. Daytime returns the date and the time. This port, whenever you will be sending a messages at the port 13, it will return you the date and the time. Port 17, it's return the code of the day, and similarly you have a lot of ports. So a lot of port numbers. Port 19, 80, the most famous one for the HTTP, and many more like this. So these are the few ports. So this is the first service. that is process to process communication. The second second service is basically the stream delivery service. So let's get go to the picture, then we'll understand this part. So if we look at this, then we will be realizing that in TCP, what's actually happening there. So it's saying that okay, TCP while doing a transmission, that it receives a message from the process. So where is the process? Process is lying at somewhere at the application layer. So it receives a message from the process that is known as your user datagram, and it eventually becomes your IP datagram. So then it sends those messages, those datagrams, whatever the datagrams do you have, it always be sending those datagrams, it always be sending those datagrams to the destination as a stream of bytes. So here is saying that okay, as you start delivering few things like the stream. So here in the TCP, the same things goes on. So the sending process deliver the data as a stream of bytes and allow the receiving process to obtain the data in the same fashion as well. So if you are sending the bytes in a stream, then the receiving side will also be receiving the data in the streams. So TCP, you may say TCP actually is creating an environment in which two processes are just connected by an imaginary tube, and tube is meant to deliver the bytes in the stream across the internet. So this imaginary tube you might have seen, but a stream of bytes will look on into few other services or few of the other features. Then we'll get to know, okay, actually this is just a imaginary tool. This is just an imaginary. So you may think like that. Okay, while sending few messages, while receiving the messages from the application layer, TCP just make a stream of a byte, and it keeps on sending the data until all the transmission is not completed. So you may think like there are four people in a row, and four people are just lined up, and the very first person from the beginning of a row give a thing to the second person in a row, the second to the third to the fourth, and fourth to the destination. So you will be saying okay, the fourth people are actually lined up and they have make a stream. They have made a line where one is passing to the second or third. So similarly, it also saying that okay, here you have a tube that and this tube is meant to send the data in the form of a stream. It's in the form of a byte from the sending to the receiving process. So let's move to the other process. Similarly, we have full duplex communication, multiplexing, connection oriented. So let's see what do we have. So okay, sending and receiving buffers. So this is another important concept, because okay, sending and the receiving process may not be necessarily about write or reading the data at the same time. All right. Are you getting this? I hope you are getting this point. Keep sending and the receiving process are always not necessary that they will be writing or reading the data at the same rate. The rate is concerned. Okay, it will be like that. Okay, I'm teaching you this point. I'm teaching you this lesson. I'm teaching you the TCP IP communication. So I'm telling you about the stream delivery point. But this is not always the case. Okay, every student in the class will be able to understand this lecture in the very first time. So you may be thinking, you may be analyzing my words, and then after a few minutes, few questions will click in your mind, and you will be raising your hands. You will be asking the same thing. So it will not work at the same rate. I'm telling you things. I'm telling you things, and it wouldn't ever happen. Okay, everyone in the class just get to know about the idea within just a second. So let's say, okay, I'm teaching you this topic, stream delivery. So you just have watched this video, uh, few part of this video. So in the last part, about uh, I was actually telling you the stream delivery. So this may not be the case. Okay, everyone in the class will get the idea at the very beginning, at once only. So this may not happen So what you will be doing? So you will need to record the lecture. You will be saying, "Okay, sir, we're not getting your points." If let's assume okay, I'm giving you a live lecture and you are not getting few of the things, what you will be doing? You will be saying, "Sir, kindly repeat your few points." This will be your first suggestion. Or your second suggestion will be that, "Okay, sir, kindly record your lecture." So there are few points which we didn't understand. We are not saying you repeat those points. We'll watch your recorded lecture. We'll watch your recorded lecture and then we'll analyze by ourselves. So this will be the second method. So similarly, Beta, you may make this analogy for sending and receiving buffer. Buffer is same like, okay, if you look at this picture, if you look at this circular picture, you will be realizing okay, there are three different portions: the white portion, the colored portion, the gray portion, and this pink color. So this pink color is depicted by as a sent byte. So these arrays will be indicating you okay, these bytes have been sent to the receiving process, to the receiving end, to the destination. This portion will be saying okay, there are bits have been loaded, bytes. So bytes have been loaded in the circular array, but these bytes have not been yet sent. So this white portion will be indicating that there is none of the bytes have been loaded in this white portion. So you may categorize these three portions as k your pink color portion is only indicating you that bytes have been sent and acknowledgement has not been received yet. And this gray portion, this you may say okay, these bytes are about to send. These bytes have not been sent. So you may make a record of these type of data at your own. So similarly, this buffer will also be created. It will be saying okay, what's the next byte we have to read, the next byte that we have received, next byte to receive. This white portion will be indicating what are the next byte that we have to receive, and what bytes have we actually our receiving process has been read, and about which bytes an acknowledgement has not been sent. So this work in this way. So these diagrams are only the analogy. You may just uh, may remember these things by a single point that actually it's keeping a record. So TCP is actually offering a service of keeping a record which bytes have been received by the destination, and for those bytes we have received the acknowledgement as well. So there are still few bytes which have not been sent. It's still available in the transmission line. It's still available. We are waiting for the transmission, but we are unable to send it as the destination has the slow rate. So you may think like that. So in the next part and the last part of this video is the is about, you may be saying, is about the segments. So although the buffering handles the disparity between the speed of producing and the consuming processes, so we need one more step before we can send the data. That is the IP layer. IP layer as being a service provider for the TCP. It's need to send the data in packets, not as a stream of bytes. So in the very first part, I've told you just to make an imaginary picture as a stream of bytes. But actually, what happens? It actually sends the data, the transport layer, as a group of number of bytes together into the packet, which is called as a segment. So this TCP adds a header to the each of the segment. Header is included for different purposes. You may say for the control purposes to deliver the segment to the IP layer for the transmission. Then the segments are encapsulated in an IP datagram. Then the entire operation will be looking in a detail what's actually the entire operation is for this. So I hope the TCP services are clear to you. Thank you so much.